Hello. In this video, we are going to begin investigating domain and range of functions. So let's begin. Example 1, we're going to examine the graph below. We have a parabola, and I actually gave you the equation for the graph as well, which is x squared minus 2. So the first thing we want to do is evaluate or determine our domain. So remember, domain is x values. So let's look and see if there's anywhere where our graph cannot be in terms of x values. We read graphs from left to right, so this line is going to move from the left to the right. And is there anywhere our graph cannot be? No. So remembering from previous classes, set notation, domain is with curly braces. Those are braces, not brackets. We have x, and then we have that straight line that means such that, x again, and then that weird E, remember, it means exist, and then we have our bolded R, which is all real numbers. So x exists in all real numbers. If we want to write it in interval notation, that is from negative infinity to infinity using parentheses. All right, let's talk about range. So we shaded inside that graph, right? Okay, because this is a parabola. And there's nothing below the graph. The graph only goes up. So that's the only part we're looking at. And where does it start? Starts at -2 at the bottom of the parabola. And it's going to go up, 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 forever and ever, amen, right? It's going to go to infinity. So we know that our y value, y has to be greater than or equal to -2. So there we see it in set notation. And if we write it in interval notation, it's from -2 to infinity. The reason we have a bracket next to -2 is because we are actually, when x is 0, our function equals -2. So our graph is touching -2. We can never actually become infinity, so it's a parenthesis. We can only approach infinity. We'll talk about that if you're in calculus one day. Okay, once again, we're going to examine the graph below. It is a semicircle. I've given you the function f of x equals the square root of 25 minus x squared. So we need to determine our domain. So let's show you the bottom of this graph. This is the only part of the graph. This is the only place where the graph exists. So in terms of domain, where do we begin? We begin at -5. Where do we end? +5. Okay, so we know that x is going to be between -5 and 5. So -5 is less than or equal to x is less than or equal to 5. And our interval notation is going to be -5, 5 with brackets on both sides because our functions are actually equal to, one function, is actually equal to -5 and 5. What about our range? We begin at 0 and we go to 5. So we know that y is going to be between 0 and 5. So 0 is less than or equal to y is less than or equal to 5 for set notation. And for interval notation, we're going to have 0, 5 with brackets as well. Now, still example 2, except this time, instead of saying examine the graph, it says to find the domain algebraically. We're gonna have to use some algebra, guys. This is so exciting. Okay, so what do we know about anywhere this function can't be based off of things you see inside the function? We know that we cannot have a negative under the square root, right? Okay. If it was a fraction, we would know that we couldn't have a 0 in the denominator. This is a square root, so we know we can't have a negative inside the square root because what happens? We end up getting imaginary numbers, right? And we're not graphing on a complex plane. The plane we just looked at was the Cartesian plane, so we're staying in the real world today. Complex will be coming up soon, so don't get too sad. It's coming. Okay, so we have 25 minus x squared underneath the square root. We need to make sure that that expression, that binomial, either equals 0 or it equals something that's positive. Okay, so there are several ways that you could do this. We're going to solve using square roots. You could factor this. We're going to say 25 minus x squared is greater than or equal to 0. Factoring would be so much fun. It would be fun. Okay, but we're going to just solve using square roots. So we need to get x by itself. So to do that, we need to subtract 25 from both sides. So we have negative x is greater than or equal to negative 25, but we don't want a negative x squared, we want a positive x squared. So we need to divide by negative 1 on both sides. Anytime we divide by a negative, what happens to an inequality sign? We're going all the way back to middle school. So going back to middle school, anytime we divide by negative 1, we have to flip our inequality sign. So instead of this inequality sign saying greater than or equal to, it's now going to be less than or equal to. So x squared is less than or equal to 25. We are going to square root both sides. What happens when we square root? We have the plus or minus, and the square root of 25 is 5, but because we did the square root, we have to include plus or minus. So our domain, the way this is going to end up working out, is still that negative 5 is less than or equal to x is less than or equal to 5. And there's our domain. But now, if you see the top, it switched to range. The range switched. It was very sneaky. So I left our work from our previous direction, same domain. I left it so we could see it because we need it. We're going to find the range. So we know our range relates directly to our domain. Our range is dependent upon our domain. So we know our domain is negative 5. So f of negative 5, if we plug that in, square root of 25 minus a negative 5 squared is going to be 25 minus 25, which is 0, and the square root of 0 is 0. We also know that we have another domain, which is 5. I don't even know what word I was about to say. So we need to do the same thing, f of 5. So square root of 25 minus 5 squared. 5 squared is 25. 25 minus 25 is 0. The square root of 25 is 0. So we know that our range is not just going to be 0 because our graph would be literally like flat. That would be saying that our only range is going to be 0. No, that's not right, is it? So we have to think about that. That's where you have to use your logical reasoning and your understanding and your math foundation to say, well, maybe I need to pick something else. So what's in the middle? What's directly in the middle of negative 5 and 5? 0. So let's plug in 0. 0 is like the easiest thing to plug in. If I can choose 0 or 1, I'm going to choose 0 or 1 every time. I also know that this is the square root of 25 minus x squared. I know it's a semicircle because I have knowledge of parent functions, so in a function family, so I know that there was going to be some height in my function, so I need to investigate my range some more. So if I plug in 0, I have the square root of 25 minus 0 squared, and so the square root of 25 is 5. So therefore, we have 0 and 5 as our range values, and so we know our domain is where x is between negative 5 and 5. So now we know our range is in between 0 and 5. And that is how you find domain and range algebraically. We're going to continue diving into functions in the next several videos, so I hope to see you next time.